Good afternoon, all. Okay, so in today's class, we are going to see about another algorithm. So this algorithm going to be the last algorithm in supervised learning. So till now we are seeing about supervised learning only, right? So in that we are going to see about another one algorithm. Okay, so that is nothing but the random forest classifier algorithm we are going to see. And the problem which we have taken today is digit recognition. So already we have seen about this digit recognition, right? An inbuilt data set which was available in the sklearn. 0 to 9 digits we will be having, and then randomly if you are passing any digit means you will be getting the correct digit as your output. So same data set, but different algorithm we are going to see. And the another advantage of like what is the difference in the random forest method is this uh, is completely based on a concept called ensemble learning. Okay, ENSEMBLE, ensemble learning. So what does this process actually means is so it is a process of combining multiple classification. If you are taking classification means multiple classification algorithm they will take. Regression means regression type of problems they will take, and they will try to solve a complex problem. Okay, and they will check whether any improvement in the performance of our model or not. Okay, so here this random forest is not a separate algorithm. It is nothing but a ensemble algorithm of decision tree. Previously we have seen about decision tree algorithm, right? So it is an another extension of decision tree only, this random forest. There in the decision tree we will have only one tree structure, right? One root node will be there, and then from the decision node will be there. Finally we will have some leaf node. Here also, instead of having one decision tree, we will be having multiple decision trees. Okay, and in different trees, they will be starting with a different root node. Okay, we have also seen various examples, right? Instead of asking a first question as, what example we have seen, ice cream or any other data set we have seen, right? Similarly, it will try to create a tree with all possibilities. Okay, by if you are having four questions means I can shuffle in four different order, right? So all possibility cases it will try to take, and then it will try to find the output for each cases. And if it is a classification type of problem means it will go for the majority, whereas it is a regression type of problem means it will go for the average value. Okay, in simple terms, random forest is a classifier that contains a number of decision trees on various subset of the given data set. Okay, in the root node, we all know it is going to be having the entire data set, right? That is not going to change, but from that, different subset is going to take and taking an average to improve the prediction accuracy of our model. Okay, so instead of relying on one decision tree, which is the decision tree, we will be having only one tree, right? So whatever it is taking as subset, that only we will be considering as the output. So instead of going for that case, we will go for the majority of prediction. Okay, so if for assumption 10 possibilities is there from the exact data set, complete data set, I can create 10 different decision tree means from this 10 different decision tree, how many of them are giving the same output? Okay, same output, how many of them I'm getting? So based on that majority, we can go for that as a final output. Okay, so in here also two methods is there. One we call it as bagging, and another one is called boosting method. So bagging is like what I have told. We go for an average or by the majority basis, whereas boosting method means first it will create one algorithm, I mean one data tree. From that you will get one output, right? So that output again will passed to the new decision tree. So likewise, let me draw and show it to you so that you can. Okay, sorry. So in decision tree, we will have only one root node. Okay, from that we will be creating some decision node. Okay, decision node will be further divided into either decision node or leaf node. Like this only we have seen one example, right? Final nodes we call it as leaf node, decision node, and then root node. And then this we call it as one branch, right? Same thing, but in the random forest method, multiple decision tree will be created. Okay, with various subset. Like here, the question is different means like first question and second question asked means here it will start with a different question format. Okay, so like that, how many possibilities are there? It will try to create. Okay, so like that, A to Z, it will try to create maximum possibilities. Okay, from that, okay, we have taken what we can take. Any classification type of problem we will take, like whether rain will come or not. Okay, and out of, okay, let me consider as five. Okay, five values are there. So out of this five, three output is saying rain will come. Okay, as an output. So for this three, output is rain will come, and for the remaining two, it is saying rain will not occur. Okay, then what this algorithm will do? It will go for the majority because most of the algorithm are pointing out to the rain will come, right? So this will help us to improve the performance of our algorithm. Okay, this is one way of solving the problem. Okay, complex problem. This type of solving is known as bagging. Okay, putting all the algorithms output in the same place and checking which is having the majority. In case if I go for a regression type of problem, here instead of asking whether rain will come or not, how much rain, you will say in centimeter, right? This much centimeter rain will occur in this particular month or this particular year. So in that case, what we will do is first decision tree is taking 20 centimeter, 10 centimeter means, and as an average we will take one output. So okay, 20, 10, 15, 5, like that it is showing means I will divide all, I mean add all the value and I will divide by 4. I will get one average value, right? That I will pass it as my final output. Okay, in regression type of problem. Okay, so another method. So this is one method. Another method is known as boosting method. Okay, in random forest we directly don't use boosting, but in the Ansible learning, I have told about Ansible learning, right? So in that one method is bagging, another method is boosting. So there what we will do is first decision tree is there, right? So after getting one output, we will pass that as a new input to our another data set by improvisation. Okay, we will do some improvement, whether it has predicted correctly or not. Okay, whether it has predicted correctly means it will be getting some points like that. If it has predicted wrongly means it will try to improve its algorithm. So each process, same four decision trees there means what it will do, first it will process with the first decision tree, then that output will be moved to the second decision tree, then again it will go to the third. Likewise, it will filter and improvise our algorithm. Okay, from the final decision tree what output we are getting. So that will be considered as our final output. Okay, hope you are able to understand what I am trying to say. In previous method, all four will run parallelly. Okay, parallelly it will run and all the outputs will be taken together. If it is a classification means it will take the maximum. Regression means it will take the average. Here the opposite. Only one decision tree will run at a time. Okay, once that process has been completed, after some improvisation, it will move on to the second decision tree, third decision tree. Likewise, how much decision tree we can able to create. So possibility of creating various decision tree, it will go, and the final decision tree value will be taken as our final output, both for classification as well as regression type of problem. Okay. This method is called boosting method. Bagging parallelly for separate decision tree will not only for classification, both for regression also. That's why I told for regression also parallelly it will run, but output it will all the output is will add and then take the average. Okay, here I mean one decision tree will run at a time, but after one completed it will go to the second, third, like that sequence. To make it easier to understand, we can say parallel bagging. Here you can say sequential. Okay, boosting means sequential, bagging means parallel. Which one will make more errors, sir? Yes, there is a possibility, like as you said, in the boosting method, in the first decision tree, if any error got means, that will be transferred to the next decision tree, the next. So in the end, you will be getting wrong output. Whereas when you go for the bagging, also some possibility of getting error. Why? I mean, error is common in all the algorithms. What type of error you may get in bagging is, what if maximum number of algorithm the decision tree is showing the wrong output? That time the decision final decision also will get modified according to the parallel decision trees. So that also we have to consider. But when it compared to the normal decision tree, when we are having only one decision tree, it is very difficult to come to a conclusion, right? Instead of having various decision tree options. Okay, that is why we go for this type of Ansible learning method. Okay. As you said, there is a possibility of getting high accuracy and then overfitting problem. We say either overfitting or underfitting problem will occur. Okay. Okay. So the problem which you're going to solve is finding the digit, and then the collected data set is going to be. So another name for this data set is MNIST, digit data set. Okay, so for today's example, I'm having a data set separately. I'm not going to take it from the scikit-learn. Okay, so as usual, digits, digits will be in the form of numbers. Okay, not as an image. Okay, each pixel value will be converted into the Excel format or CSV file format, and the output is going to be between 0 to 9. So we are having 10 classes. Okay, in the 10 classes only we are going to see the output. So if you take the data set means we will be having 42,000 rows and then 785 columns. Okay, 785 means I think 26 into 26 or something will come. You just multiply and check whether 26 or 28. So that many pixel is there means you will be getting 785 columns. Okay, and then the target which is going to be our output is going to be between 0 to 9. So 10 classes. And the separation and all are going to be same only. Okay. Only difference is, let me show the hmm, a small difference between the other data set and this one is, here they have given the label in the first column itself. Whereas in the previous data set and all, if you have seen, means it will be always in the last column, the output column Y. But here only difference is they have given it in the first column itself, and remaining all are going to be my X, which is my input values. Okay. So totally, as we have seen, we are having like 700 and some values will be there, and each value ranges from 0 to 255. Okay. In the digit recognition data set, for which algorithm we have done, anyone remember? Digit recognition, SVM or and recognition using which algorithm? No worries. So we have seen red. The difference I'm trying to say is there the range was between 0 to 16 only. If 0 means black color will be there, 16 means white color will be there, right? Whereas in this data set, it ranges from 0 to 255. Okay, 0 means like going to be black color and 255 means white color. Okay, like this our data set has been created. Okay. So small change is going to be in the splitting of the data set. Okay, same syntax only, but here colon comma one colon we have to give. Okay, usually we will give colon minus one, right, by removing last column. But here we have to start from the first column, and in the y part we have to take the dataset dot ilog colon, which means all row comma 0, which is the first index values alone we are going to take it and store it into the y variable. Okay, then splitting the dataset into train and testing part. So as usual we will be taking 70 to 80, 75 to 80 percentage for training purpose and 25 percentage for testing purpose. Okay, then here comes the algorithm part, which is the random forest classifier algorithm. So first we will see about the definition of this particular algorithm. So in this diagram itself, if you see, means here in the feature 1, okay, the red color they have marked, right, that is going to be the output. Okay, whereas in the another decision tree we are getting different output. So all this will be combined. Okay, not only two, likewise we will be having various decision tree. All values will be summed up. If it is an regression, means you will get an average. Otherwise maximum value, whichever is giving the same value, that is going to be considered as our final output. Okay, so it is considered of a large number of individual decision tree that operates as an ensemble. So which is nothing but running parallelly or running together. So this random forest split out a class prediction, and the class with the most votes becomes our model prediction. So like voting system, which got more votes, we can say maximum number of occurrence, anything we can say. So that is going to be our final prediction value. Okay, and for this we are having some hyper parameters also. So using this hyper parameter we can tune and modify our model also. Okay, what are the hyper parameters are? First is huh? Yes, yes, as classification only voting system. For regression, it will be like average. Okay, we are seeing about random forest classifier only, right? So that is why it is given like modest prediction. Okay, some of the hyperparameter are n estimators. So what do you mean by n estimator is the number of trees that the algorithm can build. So how many decision tree you want to build, that you can restrict. If you are not restricting means by default it will be none. Okay, default value is none. So it will take all maximum possibility of the decision tree available. Okay, you can restrict to minimum possibility. Like if you are saying n estimator should be only 5, 6, like that you want to minimize means that is possible. Okay, that is one of the hyper parameter. Okay, and another one, I mean few more is there, maximum features. So how much feature you want to take it into your algorithm. So here depend upon the feature, the number of decision tree also will get affected, because we are having four feature means four types of decision tree only we can able to create, right? Starting as first feature as the first question, it will be further split into two more categories. So likewise we can specify how many speech feature you want to take it. So maximum features, and we are having minimum sample. Okay, when it come to the minimum sample means how many leaf you want to create in the internal node, that also we can specify. Okay, in an minimum sample I want to take only 2, 3, then that much split up only depth, we can say depth it will take, it will not go further split up. Okay, that we can call it as a minimum sample. And then n jobs. So here n job is related to the processor. Okay, so by default if you are giving like one means it will take only one processor. Like if you are having a multiprocessor in your system and you want to increase the speed of the decision tree or the random forest method means, then you have to give -1. So if you give -1 means it will take the entire processing speed. If you're having quad core like that means entire processing speed it will take. Whereas if you want to limit the speed means you have to give 1. So if you are giving 1 means it will take only one processor. Okay, logically we are having like quad core processor means 4 that can be logically divided into 8, right? From that only one processing speed will be given to our algorithm for processing this data. Okay, why we are taking this as consideration is we have to, I have told, right, parallelly it will be running the decision tree. Okay, parallelly two decision tree, three decision tree means okay, what if 100 decision tree are running, that time minimum processing speed if you are giving means it will slow down our process, right? So in that case you can go for no limit. Okay, you can give if you are giving one means one process it will take, we cannot give 2 300, we cannot give 1 or -1. -1 means no limit, how much processing speed it needs, it will take that much. Okay, suppose the data set is very huge. Okay, that time we cannot limit to 1. If you are limiting means the processing time will take more. Okay, then random state. So where we are seeing this random state, we are seeing the random state in splitting the data into train test split, right? There only we are giving random state. But random state is not only available in the train test split, but also in each algorithm. Most of the algorithm will have their own random state also. So based on the random state only, it will start its splitting process. So here also if you want means you can specify the random state. It doesn't mean that what random state you have given in the train test split should be there in random state of algorithm. We can give different random states also. If we are not giving also not a problem. But again in this processing time if you are giving random state means each time when you run means same random splitting will happen. Okay, then so this will help you to produce the result when it has a definite value. Okay, so up to here clear. So these are the hyperparameter which are available in our random forest method. So n estimator is there. Okay, We can estimate how many decision tree you want to create, and then maximum feature. So how many leaf node you want to create. Okay, and then minimum sample. Sorry, maximum feature means how many feature you want to involve in your random forest. Then minimum sample means how many leaf node you want to create, or depth of our decision tree you can specify. N jobs, whether you want to process with the less processing speed, or unlimited processing speed, or you want to specify any random state or not. So these are some of the hyperparameter. By changing these values, you can expect a different output or different accuracy in our model. Okay, since we are taking already predefined data set, the accuracy is almost going to be higher only. Okay, so let me um, so once we have created the model, we have to train our model. Okay, and then we will evaluate by using the accuracy score. Okay, finally we will predict with some new value. Okay, here we don't give any new value, right? Because it is an pixel value already given. So we just pass some random values and we will check whether it is predicting correctly or not. Right? Okay. Let us go into the program part. Okay. So digit recognition using the random forest method. So as usual, these are common things. So I'm just typing. Pandas and NumPy you can add, or only pandas also is enough. So on the dataset name is digit.csv. So I'm just going to load it here. Okay. So let us see how much rows and columns is actually present, and we can see some sample data also just by giving print. So as we have seen, it is having 42,000 rows and then 785 columns. Okay. Then I'm going to segregate the data set into X and Y part. Okay, which is here, as we have seen in the mind map itself, we have to start with data set index 1, like I lock colon comma 1 and then colon. Okay, so X value has been taken. Similarly for Y. So first column alone I have to take, so colon comma 0. Okay, no need to give 0 colon. Right. So all the values has been taken for all the rows. Then after splitting into X and Y, I'm going to create the train and test. So from where we will get, so from sklearn dot model selection. Okay, so Okay. So for training our model, we have to import the algorithm, right? For decision tree, from which class we have taken the decision tree algorithm? From sklearn.tree, right? But whereas this is an ensemble learning method, right? So separate class is there for this type of algorithms. Okay, so random forest alone is not an ensemble learning method. We are having other algorithms also. Okay, so we are going to see about only random forest only. So from sklearn, okay, dot, here we have to type, instead of tree we have to type the n symbol. Okay, so from here I'm going to import the random forest classifier. Okay, then model creation, random forest. So here I am not going to pass any hyperparameter. Okay, as a lab exercise, you can try with the different parameters. Okay, what are the parameters we have seen? N estimators is there, and then n job we have seen. 4 5 parameters we have seen, right? From that, you try to give all the parameters, minimum, maximum. So interchangeably, you give 1 or 2 parameters, you give and check whether you can able to get more accuracy than what I'm going to get in this model. Okay, so if I am not passing any parameter, means default value will be taken for all the parameters. Okay, then model dot fit xtrain ytrain. So it is taking some time to train the model because of the huge data set we have taken. 42,000 we have taken, and then 700 something rows was there, columns was there, right? Okay, so it has completed its process. Now we have to predict it, right? So predict is equal to model dot predict x test value I'm just passing. Okay, so prediction done very fast. Now we have to compare the predicted value with our original value, and then we have to check for the accuracy. So how much accuracy we have gained from the predicted and the actual model. So for getting the accuracy, we know, right? From sklearn dot metrics, we will be taking the accuracy score. Okay, so why we are not taking a confusion matrix? Because we are having so many classes, right? So it will be very difficult to visualize the, confusion matrix. So we will just go with the accuracy score itself. Okay, from that itself we can able, both are same only. See, from the classification, sorry, confusion matrix, how we are finding the accuracy score? By adding the true positive and then false positive divided by total value, right? That same value is going to give the accuracy score also. So if you don't want me, you can ignore the confusion matrix. Okay. So sklearn dot metrics, import the accuracy score. So accuracy of my model. So accuracy score of y predict. Okay, so into 100. Okay, So let us see whether I am getting some good accuracy or not. Okay. So I have got accuracy of 96.36. Okay. In case if you are trying with the some hypertuning parameter means show me that whether you can able to get more than like 97 or 98 if possible. Okay. One more thing is, suppose you are changing in this line. Okay, as I told you, we are changing here means try to run the program from the beginning. Okay, don't run it from here. Instead of that, try to run the program from the beginning. Why? Because sometimes it will create some error. Okay, because previously run the code will be having some cache memory in your program part. So if you are running from the beginning means it will be removed completely. It will removed. Fresh run it will do. Okay, so you may not get any error. Okay, then so any doubts in this particular algorithm? I think it is a very short algorithm, similar like decision tree. So that's why it is very easy to explain also. So have you all completed your registration process, Aman Kumar, Anbuchelvan? So try to complete the registration, student registration process. So if you are completing in this month only, then upcoming month you can able to apply for the NSQF examination. Okay, so after applying for the NSQF examination, like if you are applying in 1 month means next month, next month, which month you have, maybe in November or December you will be having your final exams, right? So you have to register for that 1 month before. Then only you will get some registration number and everything will be there and your process will be completed. Okay, if you have done the student registration process means this month, this student registration will be valid for up to 5 years. Okay, so by any chance you are unable to write the exam in this attempt itself, with this student registration, you can write the exam within 5 years. If you have missed this student registration means it will be difficult for us also to process you in the next batch or next upcoming exams. Okay, so every 6 months once one batch will be completing, right? So along with that batch only we will try to conduct the examination. Okay, so previous batch, October batch, June cycle we have done one, and some students have applied in August cycle also. So for you it will be in November or December cycle. Okay, depend upon how fast we are completing the syllabus and how fast you are completing your part, which is the project part. Okay, for project also separate 100 marks is there, Viva wise. So try to start preparing the abstract. Okay, and send it to me the abstract. So if it is good means I will ask you to proceed with that abstract. Otherwise, now itself you will get option to change the project. If I say this project is not that much good, you have to make changes. Means you will get time to go for a new project. Otherwise, in the last moment, if you are coming and showing your project, and that project has been already taken by someone else, or that project has not accepted, in that case we cannot do anything. Okay. What are the projects which we won't accept is chatbot related project sir will not accept. Jazar also will be there in review like that. We will like college we will conduct some zeroth review. Okay, project presentation and all we will do. So first review is nothing but zeroth review when we are conducting only we will approve your project. Okay, in that time Jazar also will be there. So that time if he is rejecting means it will be difficult for you also. So chatbot related project should not be there. Very simple, projects which can be done by using Excel. Okay, visualization, very simple. Those kind of projects also try to avoid. try to take some challenging kind of project. Okay, it can be existing project also, but you have to work on that project and what type of modification you have done. Okay, in college and all we used to do, right? We will take IEEE paper and then we will do some modification in that paper and we will present. Likewise, you can also take some project and you can work on the project, you can do some modification and you can present. You should know everything about the project, what algorithm you have used, what that algorithm means, why we are going for that particular algorithm. So those kind of questions will be asked in your final viva also. Okay, if you have three-person doing means all three-person has to participate in that project. Okay, one person doing every coding part, another person not doing means that will not be accepted. For Viva and everything, individually we will allocate mark. Even though three-person doing same project, same mark will not be given to all three members. So individually we will ask question. Okay, based on your answer, how good you are presenting, how much knowledge you are having about that particular topic. Based on that, your marks will vary. Okay, is it clear for all? Aman, Anbuchelvan. You should have some one passport size photo, I mean scanned copy, and then your signature. So your signature should be in either black or blue only. Okay, in paper you signed and cropped image. And then third one is left hand thumb impression. Only you have to give left hand thumb, not any other thumb impression. That also black or blue only. Okay, no other color, red and all you should not use. Okay, so and the file size should be less than 50 KB. Okay, apart from that, nothing important thing you have to upload. All basic information like your full name, name and all you should give carefully. Okay, whatever your name you are giving, that alone is going to come in your final certificate. Okay, based on that only certificate will be generated. Certificate, your final marks, everything will be controlled by the HQ, not from our side. Okay, so any mistake if you are made means before I verify the process, if you have told means we can redo the process. Otherwise, once I have confirmed it and I have processed it further, because for you registration fee is there, that from Nilit Chennai they will pay. Okay, so only if you all you complete only I can able to further proceed with that process. Otherwise, if you people are doing later, so we cannot able to proceed it. Okay, that's why I'm stressing you to complete it. Okay, last date I'm giving you, before 10th to 15, you just try to complete. Okay, if you are ready with the abstract means you can send it to me. After the deep learning concept and all over means, then you will be having project also along with that. Okay, okay. What about this month? Okay, this month, take this month. Yes. Okay. Then 20. Okay. I'm giving 3 weeks time. Okay. So 3 weeks in the sense means up to 25 you take time. Not only for if you have created abstract means you can immediately send it to me. Okay. So I can able to verify and approve. Once you have finalized the abstract, then you have to start working on your project also parallelly. Okay, what type of algorithm you are taking, everything you have to do some research, self study you have to do. Okay, parallelly you will be having classes also. That's why I'm giving 3 weeks time, because for abstract creation and all 1 week is enough because you are going to search and but we are having classes, right? Parallelly machine learning class also going now, new topic MySQL has also been started. So that's why I'm giving you 3 weeks time. Okay, in this 3 weeks you finalize your team members also. Okay, two or three, maximum three only accepted, not more than that. Okay, So thank you all. See you in tomorrow's class. Practice all the algorithms. So that is why I'm not sending this source code also. So at least whatever I have typed, you will have to type and practice. Okay. Thank you once again.